All right, so here we're going to talk about optimal containers, which would be minimizing surface area. So let's think about a little context behind this problem. Your project is all about a shipping company. And one thing that a shipping company is going to look for, or any business really, is how can they minimize their cost, meaning how can they make their cost the lowest? And the one thing that they can do is make their packaging need the least materials possible. And needing the least materials possible to package would mean that they have to spend the least amount of money. And obviously, there we're talking about surface area. The amount of material we need to cover a figure is the surface area. So here we're going to take a look at a container that has a volume of 24 cubic units. And we're going to look at these using actual blocks. And you can use these blocks in class as you go through your activities, but these blocks are 1 centimeter by 1 centimeter by 1 centimeter. So they're called unit blocks because they all have a length of 1 unit. And we're going to arrange 24 of these different blocks in different ways. And since we're using 24, the volume of every single container is 24 because the length, the width, and the height of each individual block is 1. So 24 blocks is going to give me a volume of 24. So let's look at first the different ways that we can arrange these 24 different blocks. Okay, so we can start out with a nice long line. Right? If I just lay them all in a line, that's technically a prism there. And here's how we read the dimensions. We have a 1 by 1 by 24. That means we have 1 front to back. We have 1 stacked on top of each other, and then we have 24 long. So if you're kind of looking at it, the up and down is 1, the front to back is 1, but the left to right is 24. So we want to kind of do this systematically. So the next place that I can think to go is, if I split 24 in 2, I'm going to get 12. So that's going to give me a 1 by 2 by 12 prism. Notice here, the 1, there's 1 stacked on top of each other, 2 front to back, and 12 left to right. So that's where I get my dimensions. Now, if I take and I split this again, I think, well, I started with 24. I know 24 is 2 times 12, but 24 is also 3 times 8. So I'm going to take and split that 24 into 3 times 8, and now I'm going to get a 1 by 3 by 8. Now, notice this is turned a little bit differently. Some of you might be saying, hold on, this is a 1 stacked on top of each other by 8 front to back by 3 left to right. We always write our dimensions from smallest to largest. So a 1 by 3 by 8 is the same as a 1 by 8 by 3, which is the same as an 8 by 3 by 1, or a 3 by 8 by 1, or a 3 by 1 by 8. It doesn't matter. We always write the dimensions from smallest to largest, and that way we don't have any duplicates. So here I still have 1 up and down, 3 front and back if I were to turn it, and 8 left to right. Now, this isn't all of them. I go back to that original 24. I split the 24 into 2 and 12, into 3 and 8. I also know factors of 24 are 4 and 6. So the next cube, or the next prism I can make, is a 1 by 4 by 6. Again, 1 stacked on top of each other, 4 left to right, 6 front to back. And again, it doesn't matter how I turn this picture. It's always a 1 by 4 by 6 because it's in order from least to greatest. Well, I've gotten all my factors of 24 down that have a 1, but maybe I can split some of these other things up. If you remember, I had a 1 by 2 by 12, but I also know that 12 is 2 times 6. So I can replace the 1 with the 2 times 6. So now I'm going to go from a 1 by 2 by 12 to a 2 by 2 by 6. Now we have 2 stacked on top of each other, 2 front to back, and 6 left to right. Notice 2 times 2 times 6 is still 24. So really what I'm trying to do here is find sets of 3 numbers that multiply together to make 24. I can think of one more, and that would be a 2 by 3 by 4. Notice here, now, in this picture, the way I have it, I have 4 stacked on top of each other, and 3 kind of front to back, and 2 left to right. Again, I could turn this many different ways. It's still going to be a 2 by 3 by 4. Okay? So what we want to do now is think, well, which one of these is going to give me the least surface area? And maybe you already have an idea, and if you do, that's great. But in order to figure this out, we should probably just calculate them. So I went ahead and made a table here. It's got my length, my width, and my height. And notice I always called the length the smallest number and the width the middle number and the height the largest number. It doesn't matter. Once again, I just like them to be from left to right. The volume is always 24 because I used 24 cubes, and I could check that by multiplying the length, the width, and the height in all of them. So all I need to do is go ahead and find the surface areas. I'd like you to go ahead and pause your video right now, copy this chart onto a piece of paper into your notes, wherever you're doing your work, and find the surface areas, and then you can continue. All right, so you should have found the surface areas, and what we have here is 98, 76, 70, 68, 56, and 52. So I hope you're realizing some patterns here. I'm not going to give you all the answers for this because we want you to go through, and in the next part of your form, you're going to take a look at some other volumes and see if you can figure out and draw connections about how you're going to find the smallest surface area and what do you know about the smallest surface area. So as you're going through your next activities, I want you to think about these questions. Obviously, you're going to want to organize your data. So you can see which dimensions give you the greatest surface area and which dimensions give you the least surface area. You're going to go through about 3 additional examples, and it might take you all 3 to find some patterns. So I highly, highly encourage you to make a table for each set of blocks or each number of blocks, and you should include the one from this video. So you should have 4 sets of data by the end of this activity or this tutorial that you can kind of look at and help you draw some conclusions. Make sure you notice about the surface. What do you notice about the surface areas as you modify the arrangements? So if you looked at mine, what did you notice about all my surface areas? Go back to the video and look at your table. How would you describe the shape of the container with the least surface area? So we started with that long, skinny kind of, thought of it as a snake, but the 1 by 1 by 12 was very long and skinny and short. When we got to the 2 by 3 by 4, which had the smallest surface area, I thought that looked kind of boxy. It was kind of almost equal every way. So maybe you want to take a look at how else would you describe some of those things. And lastly, think about what do you notice about the dimensions of the container with the least surface area compared to the container with the largest surface area. So go ahead and you can advance your form now, and with your group or by yourself, get some blocks, arrange them, fill in your tables, find all the ways that you could make each of those different prisms, investigate the surface areas, and see if you can draw any conclusions.